Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for simplifying radicals. In this video, we're going to simplify radicals that include in the radicand both numbers and variables, and we'll talk about some strategies you can use to simplify them. Also, I just want to point out that in this video, there are going to be some example problems that I'm going to suggest you try on your own. Pause the video and give them a try. And then once you finish them, you can unpause the video and just compare what you did with what I'm doing here in the video, so you can see if you did it correctly. So let's get started with the first one. The first radical I want to simplify is rad 45. So here's our radical symbol. There's our 45. And I want to point out that the 45 is what we call the radicand. The radicand includes everything under the radical symbol. Also, we have the index. So the index, if nothing's written there, it's assumed to be 2. And the index is the root. So for this one, we're taking the square root of 45. But we want to try to simplify it. All the problems in this video, I'm not going to write anything for the index, so we're taking the square root of all of them. Let me just rewrite radical 45, and let's get started. So the way you want to begin simplifying radicals is to think of factors of the radicand. So some of the factors of 45 are 1 and 45. We have 3 and 15. And we have 5 and 9. And what you want to do is you want to find the factor that would be the greatest perfect square. 1 is a perfect square, but there's a larger one, and the largest, greatest perfect square here would be 9. So what we're going to do is we're going to rewrite this radical 45 as rad 9 times 5. Next, what I'm going to do is I'm going to rewrite this as 2 separate radicals being multiplied together. Now we have rad 9 times rad 5. What allows us to do this is something called the product property of square roots, which says that if you were to multiply 2 radicals together, you would just multiply the radicands and rewrite it, product of that under one radical. Now the square root of 9 is 3. We can't take the square root of 5, that's the most simplified. So that's our final answer, 3 rad 5. So let's do example number 2. So example number 2 would be 9 rad 75. And you want to begin by listing your factors of 75. You don't necessarily have to write them out, but I'm just going to do that for this video. So we want to look for the greatest perfect square. Again, 1 is a perfect square, but that's not really going to help us in this one. We have 3 and 25. 25 is a perfect square. There's also 5 and 15. 3, 5, there's 5 and 15. But I think 25 is the greatest perfect square. So let's use that. I'm going to rewrite this 9 out here. And under the radical, we're going to do 25 times 3. Now I'm going to use the product property of square roots. I'm going to write this as 9 times the square root of 25 times the square root of 3. So we can take the square root of 25. That's 5. We can't take the square root of 3. That's the most simplified it can be. And in our last step, I'm going to multiply the 9 and the 5. And multiply the rad 3. And there you are. That's our final answer. So let me give you a couple that you can try on your own. So question 3, we have 2 rad 96. And then for 4, have 4 rad 216. What you need to do is try to find the greatest perfect square factor and try simplifying it using that. So if you finished it, I'm going to go over it now. So I rewrite the 2. We can rewrite 96 using 16 and 6. So I'm going to rewrite this as 2 times rad 16 times rad 6. And we can take the square root of 16, that's 4. And to finish this, I'm going to write 8 rad 6. And that is the most simplified we can rewrite this. Number 4, I'm going to rewrite 216 as rad 36, 6. Now I'm going to rewrite this as 4 times rad 36 times rad 6. Square root of 36 is 6. And now we have 24 rad 6. So now let's try some examples using variables. Let's start with radical 512 a squared. All of that under the radical. So we're going to do this the way we were doing all the previous problems. We need to find factors of 512, one of which being the greatest perfect square factor. The factors that we can use for that would be 2 and 256. Rewrite this k squared. So now I'm going to rewrite this as rad 2 times rad 256 times rad k squared. Now rad 2 is the most simplified it can be. We can take the square root of 256, that would be 16. And we can take the square root of k squared. That would be simply k to the first power, or you can just write it as k. I'm going to rewrite our final answer, moving the 16 and the k in front, and then multiplying it to rad 2. That's our final answer. So here's question number 6. By the way, there's a total of 9 problems if you're wondering how many there are. So we're almost there. This one's pretty similar. I'm going to use 512 again. But I'm going to do m cubed. I'll show you what happens when you have an odd one, an odd exponent. So we know from the previous problem, this is rad 2 times 256. What I'm going to do is, off to the side, I'm just going to show you m to the third power. We can rewrite that as m squared times m to the first. We could do that because if you recall, when multiplying variables, you add the exponents. So what I'm going to do is I'm going to rewrite this as m squared times m to the first. And just like the previous problems, I'm going to separate these into different radicals. So we have rad 2. Square root of 256 is 16. Square root of m squared is m. But we can't take the square root of m to the first. That's the most simplified it can be. So we're just going to write radical m. I'm going to reorder this. It's m times rad 2 times rad m. And in our final step, I'm going to write 16m rad, and I'm going to combine rad 2 and rad m be rad 2m. When we multiply radicals, we can rewrite their product under the same radical. So let's do number 7. And then the last two I'll allow you to try on your own. This is rad 75 x squared y. So we have two different variables here. So we did 75 before. I want to write that as rad 25 times 3 times x squared times y. I'm going to separate these into different radicals. We can take the square root of 25, that's just 5. We have rad 3. The square root of x squared, that's just x to the first power. We can't simplify rad y any further. I'm going to leave it as that. I'm going to reorder this. And in the final step, I'm going to write it as 5x rad 3y. And that is how you simplify. All right, so please copy these two problems down. Got 8, which is rad 64 m cubed n cubed. And problem 9, which is rad 200 m to the 4th n. So please try those on your own. So let's go over them. So I'm going to begin by separating these. We can take the square root of 64 actually, so that one's pretty nice. But I'm going to write this as m squared times m. I'm going to write rad n times rad n. So the square root of 64 is 8. Square root of m squared is m. Can't simplify rad m. Square root of n squared is n. And rad n stays rad n. We reorder this, get 8 times n rad m n. And for 9, I have to read really quick. Rad 200 to the 4th n. So we can use 2 and 100 times n squared times n squared n. I'm going to separate these. Rad 2 can't be simplified any further. Rad 100 is 10. Square root of m squared is m. So is that one. And rad n is going to stay as it is. If I reorder this, that. And in our final step, write 10 m squared rad n. Now, I just want to point out really quick, there is a little bit of a shortcut to this. Over here, if you look, we had, if you look at 2, let's see. So if we look at the square root of m to the 4th, what you can do is take the 4, the power, and divide it by 2, which will give you 2. That means that your answer to this problem would be m squared. And here's another little example. If you have square root of m to the 5th, what you would do is you do 5 divided by 2. And that would give you 2 with a remainder of 1. That means that your answer would be m squared. This tells you what that power would be. But you have 1 remainder. That would be your 1 right here. So that's a little shortcut that you can use when simplifying these. So that's it. I hope you enjoyed the video. See you in class. Thanks for watching.